Hello everyone and welcome back to the Captain DevOps YouTube channel, and today we'll be taking a look at the choose and deploy models from the model catalog in Azure AI Foundry portal section of the AI 102 Microsoft Learn Path. So as you know, we are studying for the AI 102 exam from Microsoft. And every single day in the month of July, I'll be posting a video with my progress, and I'll be taking you guys along to see where we can get at the end of the month. So maybe let's take a look into this module, right? So what we are going to learn here is pretty much how to choose the various language models that are available through the Azure AI Foundry, and we will be able to select a language and a language model rather, deploy the model to an endpoint, and test the model and improve the performance. So maybe let's start. Sorry, clicked on the wrong link there. Start. So here is some things that we already know, that the applications are built on models. Usually we compare foundation models, which are models like the GPT-4 Omni or maybe the Llama models, and we find the one that suits the best the particular needs of the application. And after selecting a model, we deploy it, and it can be then consumed by a client application or AI agent. And AI agents is something that we are going to look at very carefully in the next videos, but for now, let's just keep it as it is. So the foundation models are the language models designed to understand generally the human language. So these are a couple of use cases, so speech to text, machine translation, text classification, entity extraction, summarization, question answering, and reasoning. And today we'll be taking a look at the foundation models used for question answering, and they can be used for chat applications. What else? The latest breakthrough is the development of the transformer architecture. So the transformers were introduced in the Attention is All You Need paper, which is a very famous paper, I think by OpenAI, which created the transformers, as I said in the previous video, the RDT in the GPT. So the GPT stands for Generative Pre-trained Transformer. And here are two important innovations to natural language processing. Instead of processing words sequentially, they process each word independently and in parallel by using attention, and they also use positional encoding to include the information about the position of a word in a sentence. So maybe let's see where this link takes us just for a second. So this is the Cornell University webpage, and we can see the PDF here. And here it is. Sorry, it's not the OpenAI that made it. It's a Google research paper, so I'll stand corrected on that. But yeah, this is the actual research paper that provides the model architecture for the transformer. And as I said in the other previous videos, the 3 Blue 1 Brown channel has a lot of very cool videos about this sort of thing that I won't be diving into deeply in this series. But yeah, let's see what the model catalog is about. So this is a print of the model catalog in the AI Foundry portal, and we already took a brief look into it on the previous video in which we deployed the actual project. So there are a lot of models, and so there are a couple questions that we can use to choose a model. So can I solve my use case? How do I select the best model for my use case? And can I scale for real world workloads? So let's see. Can I solve my use case? We need to discover, filter, and deploy a model. And there are a lot of available places that we can use to test models. So Hugging Face, GitHub models, which is a very I didn't know about this, but you can pretty much go to GitHub and start talking with language models here. Here, let's see. Yeah, add button, and then follow the instruction to authorize the app. So you can also do this directly in GitHub and the actual AI Foundry portal. And we can maybe, this already makes things much easier for us, because we can then, for example, already test some very rudimentary version of the test that we are trying to do with the AI model on the chat itself. So we have that. We can choose between large and small language models. So yeah, the large language models, they are more powerful. Are better for tasks that need deep reasoning, complex content generation, and extensive content understanding. And the small language models, they are efficient, cost effective, and but they can still handle many common tasks for natural language processing. And here's the use case for them, which is the lower end hardware or edge devices. So maybe you want to run sort of an AI model on your phone, and you don't want to have maybe you want to ensure that the model is able to run. I'm not sure if this is a good use case for, because I'm not sure if these models specifically are able to run on phones, but whatever. Um, the key thing here is the cost and speed are more important than the model complexity, and this is the key factor that we can use to choose between a large and a small language model. So focus on a modality task or two. So here, let's see, when you need high levels of performance, you can use reasoning models like DeepSeek R1 and O1. So these are the reasoning models. They are they sort of create a plan, if I believe, and then they have sort of an inner monologue of how they are trying to answer the question, and then they can sort of question themselves and verify that they are on the right track behind the scenes. And all of this is verifiable in the actual chat usually. Beyond text-based AI, some models are multimodal, so they can process a lot of things. Let's see, multimodal models are useful when your application needs to process and understand images, such as in computer vision or document analysis, which is very handy. What else? What else? Generating image, that is the Dolly and Stability AI models. The embedding models like Ada and Cohere. So these types of models, they convert text into numerical representations, and they are used to improve search relevance by understanding semantic meaning. This means that if you pass some sort of information, maybe a text, through one of these models like Ada, then it will be this is a model that receives text and converts the text into a very large string of floating point numbers, which we said earlier, which is a vector. It's called a vector, and yeah, is the numerical representation are that. And if we want to, this is very useful for search engines, since we can maybe we have like a very huge list of embedded informations in the form of vectors, and we want to search for something on that database we have. Maybe we can get the search text and put it through the model as well, and then it will also become a vector, and we can compare the vector of the search with the other vectors that we have stored. So yeah, these models are often implemented in the retrieval augmented generation scenarios to enhance recommendation engines by linking similar content, which is also something I talked a bit about in one of the previous days. So when you want to build an application that interacts with other software tools, you can add function calling and JSON support, which is also very handy. Specialized with regional and domain-specific models. There is there are language models targeting specific languages. What else? Time series forecasting. So yeah, there are a couple of very specialized models that we can also use instead of only GPT-4, for example. And yeah, open versus proprietary models. So they are best for cutting-edge performance and enterprise use. So usually OpenAI, Mistral, Cohere, and the open source models are flexible and cost efficient. So Meta, Databricks, Snowflake, NVIDIA, Hugging Face, all of these providers for open source models that we can use. What else? Yeah, and we can ensure some other requirements here, so data and privacy, security and compliance, and the responsible AI and content safety recommendations. So, but even though this is written here, on the proprietary models, OpenAI doesn't really get the text that we are sending to the model if we use it through the AI Foundry, for example. but I believe there are some other considerations here, which I'm not exactly sure enough to talk about in this video, but let's move on. How do I select the best model for my use case? So we can like define the four characteristics, which are test type, precision, openness, and deployment. So the task type is like only text or also audio, multiple modalities, or one specific thing. The precision is that we can use a generic model and it works fine, or maybe we need a more specialized model for a specific skill. So maybe time series forecasting for the financial predictions, for example. The openness, so maybe we want to actually fine-tune the models ourselves, which in most cases isn't really necessary. Since you probably need a lot of expertise to actually fine-tune in a way that's actually worth it. But yeah, we can also choose according to that if we want, and we can choose to deploy the model locally on or on Azure, and if you want or not to manage the deployment infrastructure. So yeah, filter modules. So maybe let's see. This refers to the accuracy of the model in generating correct and relevant outputs. So the proportion of true positive results among all generated outputs, so high precision means fewer irrelevant or incorrect results, making the model more reliable. Yeah, this is just like a very basic text that says that we have all of these parameters here that we can use to evaluate a model. So, and these are called benchmarks, and all of these benchmarks, I think I showed this in the other video, but they can be like ranked against other models as well, and then we can use them to sort of make a better informed choice on which foundation or base models we use for our application. So we have accuracy, so the correct answer according to the data set, the coherence, which is the resemblance to human language, the fluency, so how natural sounding the responses are, the groundedness, which is the alignment between the model's answers and the data, which is a bit different between the accuracy, the GPT similarity, which is the how similar the responses of the model are to the actual input text. The quality index, which not sure what it's about, but apparently it aggregates all of the other factors here, and the cost. So price per token, which is also very good. We are usually going to want to get the biggest bang for our buck, so usually we are going to find for most applications the most cost-efficient model that still meets a certain quality standard, which is very good. What else? We can consider manual or automated evaluations, which is something that we are going to look at in a couple of videos, I think. But the evaluations are sort of like unit tests in the context of traditional software development. But if you aren't aware of what they are, maybe we can also give a brief introduction when we get there. So, yeah. What else? What else? Manual evaluations, which is pretty much just asking the model in the chat playground something you want, and then verifying that the response is is up to your standard. Let's see. And how can I scale for real world workloads? So the deployment, monitoring, and optimization, which is also very important. We need to monitor how the model is being used. The prompt management, so orchestration in this case, and the generative AI operations, or Gen AI ops lifecycle, which is one of the variations on the DevOps term from software engineering. And we are also going to talk about a lot. We're also going to talk a lot about this in the next videos, which is personally I'm very specialized in DevOps, so this is my background today. So I have a lot of opinions and a lot of things to say about this particular topic. Yeah, visually confirmed solution tools that can help you build and maintain a scalable generative AI solution. So deploy the model to an endpoint. Let's see. Why deploy a model? this is the thing that I was talking about, which once you deploy a model, it's pretty much very similar to an API, to a traditional API, that you have an application that can consume it and send a request and get a response back. Usually these requests are using REST, which is the very industry standard way of formatting HTTP requests to a certain internet endpoint. And this is just a model, a little diagram that explains this. And this is an example of the URL. So here we can see that this is a project on AI found on Azure OpenAI actually, called AI Hub Dev Demo. And we are calling a specific OpenAI deployment called GPT-3.5 Turbo, and we are calling the completions API using this specific version right here. So yeah, it includes a lot of information that we can use to identify the actual model, and maybe if we have other models or other versions or even other tasks for that particular model, we can differentiate them using the URL. What else? We have several types of models available, so this is also something that we touched a bit. So yeah, the associated cost depends on the type of model you deploy, which deployment option you choose, and what you are doing with the model. So here are a lot of options. So you have the OpenAI service, the AI Foundry models, serverless compute, and the managed compute. And there's a little table talking about all of them. So the inferencing cost, you can see that it only applies to everything that we don't provision ourselves. Because if we use the managed compute option, then we are paying for the minute. So here, charge per minute. What else? Serverless compute, minimal endpoint cost. Hosting service, the AI project resource. So we saw that in the previous lab as well, which was the resource that we were working with in the AI Foundry portal. And yeah, awesome. Let's see. Optimize model performance. Let's see what we can learn about that in the next module. Let's see. How we can use prompt engineering techniques to optimize the model's performance. And this is a very long series of paragraphs here, but we are going to go through it together. So we can apply prompt patterns to optimize the model's output. So this goes a bit into the prompt engineering, which is which are some patterns. So instruct the model to act as a persona. So for example, say that you can tell the model that he or that they rather are like a, I don't know, a specialized financial market specialist, and guide the model to suggest better questions, which is also good. So maybe in this case, this means saying that you should answer like so and so, for example. Provide a template to generate output in a specific format. So you can also provide examples in which you say, maybe I want, as an example, I will ask you for this sort of thing, and you can answer this example response that I am expecting. Understand how a model reasons by asking it to reflect, and act context to improve the accuracy of the model's output. Yeah, that's very good. And all of this forms the system prompt. So the system prompt is what we also took a look at in the playground in the earlier video, which is the prompt that sort of contextualizes everything for the model, as well as the chat history and the current chat message that it's trying to complete. So yeah, what else? What else? Instruct the model to act as a persona. So yeah, system prompt, no persona specified and with persona specified. And here's an example. You are a seasoned marketing professional. If you're working in sales and need insights about a new CRM software. So system prompt, and these are, yep. This is a comparison between the different prompts. Ask for better suggestions. So you can ask, right? So yeah, there is. So the difference in the questions here. You're an AI chef who can advise on menus, and you're approachable and always want to provide the best advice you can. And this is the comparison between the two prompts here. So what should I cook versus what should I cook, and what other information do you need to help me plan a great meal for my guests? So you can think about it as the output of the answer, the outcome, the quality of the outcome is only as good as the quality of the questions you give it. So it's a bit related to that concept. So you can see here that it has a longer response, it has like more directed advice, and so on and so forth. The desired format, so this is what I saw, for example, and sorry, the example, right? So format the result to show the match date, location, and the two teams competing. So it is just that, and the notable events. Whereas if you don't specify anything, it just outputs a generic text. What else? Explanation of reasoning. Sorry, I think this is also. You can also use one-shot or few-shots approach by providing one or more examples to help the model identify a desired pattern. So yeah, this is what I was talking about, of providing examples of the format. So maybe instead of saying format the result into this, this, and that, maybe I can give it an example answer, and the model itself will figure out how it can best match the example I gave. Or examples, right? We can use few-shots approach. As for an explanation of reasoning, so you're an AI math assistant, you always explain your answers. So yeah, this is the very big difference here about like a very basic Pythagorean theorem question. And add the context. So when should I visit Edinburgh versus when should I visit Edinburgh? And I'm particularly interested in Scotland home matches in the Six Nations rugby tournament, so it sort of tailors the answer based on the context you give it. The optimization strategies, so there are a couple of them. So yeah, a full exploration of how to apply the strategies is beyond the scope of the module, so this is just a conceptual understanding of the strategies. So prompt engineering can be effective, but it's usually like very at the end of the process, because the model is already deployed and it's fine-tuned and it already has all of the data it needs, and the prompt is just pretty much like putting a band-aid on top of all of the other setup that we needed to do. Sometimes it's useful, but maybe it doesn't cover everything that we need. So we can use the retrieval augmented generation, which pretty much, as the name says, when the model is going to generate the response, it can augment the response by retrieving information from another data source that it has access to. So yeah, it can be useful. It can be a useful approach when you need the model to answer questions based on a specific knowledge domain, or consider information related to events that occurred after the training data on which the model was based. So we saw that for GPT-4 Omni, for example, the training data stopped at September 2023, and using RAG, by using RAG we could, for example, get details of events from the last year, for example, which was 2024. Also, there is fine-tuning, which is extending the training of a model by example prompt and responses that reflect the desired output format and style. And yeah, here it just says that those are more complex. So yeah, it's usually best to start optimizing through prompt engineering and only use the additional strategies if it's really necessary. So here it is. So there's a little two axes here. So the context optimization, so what the model needs to know, and the model optimization, how the model needs to act. So we can make our choice based on this. Those are not the only options we have when we want to optimize models, but this is a very good starting point for the later stages of optimization techniques that we are going to use. Yeah, and we already talked about a lot of this. And this is another lab, but I think this is probably going to be very similar to the lab that we did earlier, because this is just exploring the models, going to the AI Foundry portal, deploying the GPT-4 Omni, and taking a look at the benchmarks, which we did extensively in the last video. But here we can use the comparison tab to sort of pitch two models against each other. And maybe once we have the opportunity to do something else, maybe we can go back and do this. Because if I think then we are going to take too long in this initial phase of conceptual understanding and like very shallow explanations about it, right? And that's it. Let's maybe answer these questions here. So where can you test the deploy model in the Azure AI Foundry portal? And this is the chat playground. We want to specify the tone, format, and context for each interaction. What should you use to customize the model response? This is the system message. The benchmarks are the metrics related to a specific model, and the grounding is a term for when the model is answering based on a specific set of data that you provide to it. So those are the wrong answers. What deployment options for OpenAI model incur no cost for deployment and charge for inferencing based on token base? And this is the either Azure OpenAI, let's see, or Azure AI Foundry models, because the OpenAI models can be deployed using those two methods. So let's see. And these are all correct, and we finished this module. So in the next module, let's just complete it to get the little badge here. Awesome. So let's see, develop an AI app with the Azure AI Foundry SDK. So we are going to create a chat client and create a generative AI chat app. And maybe this will be a very good opportunity for us to set up our development environments and introduce a bit about my standard stack for working with pro code scenarios these days, which involves using VS Code, dev containers, and the Azure Developer CLI to get started with the foundation for the projects and also the deployment, right? Maybe in a separate video, maybe I can talk about how my programming setup evolved from, just basic Visual Studio Code to NeoVim and all of those crazy integrations, and then back to VS Code in my case because of very particular requirements that I'm having here. But yeah, I'll see you guys on the next video, and remember to like and subscribe. And if you have any suggestions or anything you want to learn, you can say that in the comments, and then we'll talk through that through there. So that's it, and bye bye.